Uh, oh, are we missing Gijs? So I just want to do a quick introduction to Rob Coleman. He runs operations at PickNik and is kind of the business brains behind what we're up to. And he'll be running the panel today. He's also my brother. Thanks, Rob.
Yeah, so as Dave mentioned, we're going to be conducting a panel here now, and the topic of the panel is about MoveIt's ideal user. Joining me on the panel here today is Michael Ferguson from Botnuvo, Kei Okada from University of Tokyo, Mark Moll from PickNik and formerly Rice University, known for OMPL, and lastly, Gijs from TU Delft. Oh yeah, yeah. I'm the pronunciation. You know, Okay, perfect. So yeah, we're going to be getting started with this. Yeah, we really wanted to think about MoveIt in terms of long term, like when we're thinking about the user, who is the ideal user? And so we have a few different questions, and we like to have get an idea from your guys' perspectives, who you think the ideal user is. So if I can point that to you, Michael, to begin with, I know this is a broad question. We're trying to narrow the scope and further along. But if you were thinking about our ideal user from academia, industry, and startups, who do you think our ideal user is?
People who open pull requests that are well documented code. No, no, I think it's developers who are building manipulation applications, right? I think today it's still a relatively high technical level, right? There are some things out there that help you get into it if you're not at that high of technical level. Sort of reference designs, robots that are like pre-configured with MoveIt out of the box, I think really is a great introduction.
Mm-hmm.
So I think MoveIt can be used for everybody, but so far the current state is mainly focusing on the academia or developers. So I think current direction we should take is how we can make MoveIt more good interface for everyone, not for the interface for the planning algorithm, but for interface for people who want to use the manipulator robot.
Mm-hmm.
Yeah.
So in my mind, there are these sort of different groups of users that have maybe conflicting needs. So for education, you can differentiate between maybe academic research and students who are learning about motion planning. For them, I think it's really helpful to have sort of a reference implementation of an algorithm they may read a paper about and have a clean implementation they can look at, sort of, okay, there's source code that is very different from pseudocode, but sort of still recognizable. But for the real world, you often have like, well, actually you need to have this whole bag of tricks. It really make it fast. You have to do all kinds of things that kind of pollute the sort of elegance of the simple solution that you see in the papers, but that's what you need to get real work done. And trying to balance these differing needs that for real world performance, that solve real problems and recognize that the same algorithm is not useful for everything. But at the same time be cognizant that there's people who are still learning about motion planning and they may want to look at MoveIt and use it as an educational tool. That's very difficult, I think, to balance these different needs. So yeah, I'll leave it at that.
I took the question a bit more literally, because it sounded a bit like you were describing how we should change MoveIt to suit different kinds of users. And I was more thinking from the, sort of the industrial perspective. And there's more of an approach like, okay, what can it do for me right now instead of what can it do in, I don't know, a year or 5 years. The more you're interested in what it can do right now, they need a solution. And there I think the ideal user of MoveIt would be one that is currently just not served by traditional automation techniques. So we saw the builds planner, which is actually great. I use it myself. I'm a big fan of it. I'm very happy that we could support it with Roboitcs and Roslyn. But if you need anything more than straightforward, pick and place, very constrained environments, anything with dynamics in it, anything with changing environments, those kind of things, free motion, collision planning, I think those kind of people would be the ideal users of MoveIt, at least from an industrial perspective. So if you have the feeling that your current solution is just not doing it for you, then you should start looking at these kind of software technologies, I would say.
Right, and I think, you know, Mark alluded to this a little bit as well with how do we make MoveIt more ideal for these different user groups, right? How do we change it, and maybe if you disagree that we should change it, you know why? Can I point it back to Michael down there?
I think a lot of it is, you know, there's sort of a current workflow that's kind of expected, right, in MoveIt, right? And you can sort of trace that back to like its origins of like, hey, we needed to make the PR2 do arm planning, right? And we wanted to use our vision sensors and those sort of things. And so there's sort of this sense plan act built into it. Dave alluded earlier today about things of getting, you know, more real-time control built into it, things along those lines, so that you can be a little bit more reactive, which is, I think, also the same sort of thing that those users that are trying to do more than they can get out of the box with what's included with their industrial robot, that's what they're looking for. You know, if you're doing mobile manipulation, right, like your environment's going to be changing on you all the time, sort of thing. So I think expanding sort of the capabilities there, so that you have, you know, alternate approaches available, because there's really not, motion planning is super complex, and there's not really a one-size-fits-all that's going to work for everybody. Yeah.
What was the question?
Basically, how do we make MoveIt ideal for these different user groups?
I think that's a very difficult question because everyone has a difficult needs. So I think it's a common question that how we can keep the stability and also flexibility things. And yeah, but I think, so if you think about the stability, people who need the stability is basically for the industrial users or beginners, and they do not want to go into the very detailed with algorithm. They just want to move the robot. Or so, especially they don't care about what's happening behind that. I mean, so today I heard a very nice talk from people, PILZ. They talk about the line control or circular control or point-to-point control. And people who love, most of industrial people think robot motions in such a way, and they don't care about the, you know, if there is, you know, optimization process working behind that, or it's just a simple calculation. They don't care about that. So I think that from my point of view, it's possible to have a stable API and also other API. And once we have a set of the, you know, subset of the MoveIt API, which is we call that stable, and if we can guarantee that we won't change this one for the MoveIt 1.0 or 2.0, and people are very free to, or I can say, confident to use that API if you like to have a stable one. And people who want to go into the advanced, how can I say, features, then they only change the, you know, non-stable APIs. And I think this kind of things makes the code a little bit not cleaner because you have a very similar APIs. But from my understandings, Windows do this way because they have, for example, get handle API and get handle EX2, maybe extension API, and get handle extension 2 API. So it's from my point of view, it's very dirty API. But it makes sense because if you are using the old Windows, they only use the no EX API, and if you use the, you know, some level of the Windows, they only use the EX1. So it's very easy to understand, and that is very one way to, you know, keep balance between stability API and also advanced or, you know, I can say sandbox API or something. I don't know how to call it.
Yeah, I think along similar lines, providing different levels of abstraction to get access to functionality is useful, and that also allows you to basically, given the same API, have, you know, the dirty bag of tricks that gets the jump fast, done fast, and another implementation that conforms to the same API that does maybe things in a more elegant way that is more understandable, it's useful. It's tricky though, because we have this move group interface now in MoveIt that is really targeted towards beginners, but as soon as they start doing more difficult things, we basically say, well, don't use that. Use the lower level functionality, and having a path between sort of the easy entry point and more advanced interfaces is difficult. I don't have a good answer for that, but that seems tricky to sort of have a nice way to migrate people from sort of the initial experience of, okay, here's this, go from A to B and nothing else, and everything should just work, and then eventually discovering the limitations and wanting to fine-tune the results that you get is difficult. I don't know what the solution for that is.
Yeah, and if I can expand on this a little bit more, I guess how are we going to balance the needs between industry and academia other than these, which you guys have just mentioned?
Well, the typical answer to that would be create a super stable version that never changes and does everything, and then do the rest of your play work in something else. So I think this all sort of touches on what Felix also said this morning. There should be sort of, I think that's what you meant with default, right? It should just work for the simple cases, basically. No one should need to go into this black box, which is admittedly very faulty, and does all have these flaws, and you need to actually read the code to see that compute Cartesian path does all these weird things that you don't understand, and then you don't know how to deal with that. You have to post on Ross answers and everything. I mean, that's what should work out of the box, but if you want to, you should be able to still fix all of it. So, but for an industrial user, he doesn't care. I mean, he doesn't care what you do internally. It needs to work. And I also don't necessarily care, that it's experimental or something like that. As long as there's someone or someone's who tell me that if I use this and this and this, it will work. If it doesn't work, you come to me, and then I can either fix it, or I will tell you how to fix these things. That's I think the most important part that I've heard from discussion with industrial users. Apart from actually sort of, that comes down to documentation again. I say branding and information. In the industrial space, MoveIt, at least the companies I talk to, but maybe that's a bit sort of a selection bias. They have the feeling that it's either it's too complex, it doesn't do what I want, or if it does something, then it's weird and I don't understand why it does this. So I think that also comes down to what you just this morning told us. That's something that you really need to address. I'm not sure whether the problems are really technical in that perspective. It's basically just get people to understand that this actually works, and you're already doing that with PickNik, I would say.
And do you think that adding a higher level layer of abstraction would help industrial users be able to engage with MoveIt easier while still allowing additional changes when need be?
Yeah, because at least from a software engineer's perspective, abstraction is nice because it allows you to hide implementation details, but it also allows you to change implementation details as long as you make sure that the semantics of that abstraction are kept in, sort of in place. So even if you change everything under the hood, as long as that abstraction keeps working, no one really cares. For industrial users, I would say, within Ross Industrial, we've actually talked about getting some sort of layer on top of MoveIt, which allows you to do the move lin and the move circ and everything we just saw, but maybe actually with collision avoidance, those kind of things, and with a state representation and a world model and everything. But I don't see any of that. I just say go from here to here, maybe in tool space, maybe in worlds. I don't care necessarily. That's basically what this build planner is doing for me, but it doesn't. There was a very specific comment, right? We don't do any collision checking. Well, maybe I would like that. Maybe I would like to have this whole motion optimized, but my interface is still move lin and then to a certain point. So yes, adding abstraction can help, also with being able to still play under the hood. But obviously, I think that sort of comes to Dave's open letter this morning. I'm not sure that's a sort of valid model here because it will restrict you on what you can do. Right. Because you have to maintain compatibility with that new abstraction that you added.
Right. Yeah, definitely.
So I think, we're talking about like abstractions and APIs and whatnot. I think one of the things we could learn potentially from the nav stack, right? I'm a maintainer on the ROS navigation stack, is to use plugins sort of all over the place. We have it in about half of MoveIt, where there's like various things where you can swap things in and out. I gave a talk a couple of years back at ROSCon about how we used the navigation stack at Fetch Robotics when I was the CTO there. And with the plugin interface, when you're in industry at that point, you can start with something that's demoable at day one, right? You've got your defaults. But then you can start replacing individual pieces without ever having downtime, right? So you're going along, you're like, hey, my local planner, it sucks, I'm going to replace that. And then, okay, well now the weak link is the global planner, you replace that. But you're always keeping those APIs that, the plugin APIs, and you never really have downtime along the way. And like I said, I think we have that in about half of the interfaces in MoveIt. Like you can choose like your time parameterization is got a plugin API. The planners all come in through plugin APIs. The collision environment's like half plugin API, and the world planning model's really not, or the world model's really not a plugin type environment. So I think that's a really big opportunity when we're working on this, MoveIt 2 and ROS 2, and hey, we have no API stability at that point, so we have a lot of opportunity to sort of go back and make sure that the other half of those things become pluggable.
Right. So, yeah, go ahead.
And also abstraction layer. Today, I didn't hear no one is mentioned about that, but I like the packages called MoveIt commanders, and it has very nice Python APIs. And whenever I teach students or beginner students or industrial people to introduce MoveIt, we're starting from that MoveIt API because it's very close to the previous command motion task commander or something. So you just create the object of the robot and simply call that robot move positions or robot move go or plan or something. Then robot can move. So I don't know why MoveIt this community is not so much pay attention to the Python interface because of he didn't like Python, I think. But I personally like the very interactive programming, as you know. So, and that is very good for a beginner to play with a robot because you can type the command and at the same point you see the robot is actually moving, and it's very nice, especially for the recent robot for the human cooperation robots, like without safety bars. So I think we should put MoveIt commander as a stable API. And from the user, if you promote that, if for the industrial user or a user who do not want to change the API or need a stability, we promote them to use the Python API. And we don't change that one. But we can change the underneath of the Python API based on the request from the developers or people who like new algorithm. So that could work for everyone. And also, I'm very curious that why navigation stack doesn't have a Python API as well. Because it's also a nice algorithm API.
So I like Python a lot, and but the difficulty that a lot of software packages have is documentation. We keep hearing it all the time. And now by adding another language interface, you kind of double the maintenance for documentation because you have to now maintain documentation for the Python API, documentation for the C++ API. You have to keep updating the bindings for Python that basically hook into the C++ code. I keep going back and forth about that with OMPL. We have a programmatically generated Python bindings, and it's like one of the steps that always fails for people, and it's like, oh, I should never have done that. I should have just kept it a C++ library. It's such a pain to maintain. Documentation is non-existent for Python because it's already enough trouble to do it for C++. So yeah, it's kind of, it's really handy for beginning users to just type commands and see the results right away. But as a developer, from a developer's point of view, it's like, well, it's kind of doubles the maintenance. So.
Very good. So just to look at this from another perspective, with in terms of the scope of MoveIt, with perception, grasping, planning, all these different aspects, do you think it's good where it is now? Should it be expanded? Should it be more minimized? What should be the scope of MoveIt now and going into the future?
Well, we just had a similar discussion actually over lunch, but then at the scale of arcade solvers with Roberts. I'm actually a large fan of delegation of responsibilities, so separation of concerns, not sort of mesh everything together for two reasons, actually, or at least two reasons. One is it keeps it clear for also the maintainers, but also for users where they should go for particular functionality, and two, it keeps maintenance effort low. Not low in the sense from you don't need to do anything, but more, you don't add additional functionality that suddenly now also needs to be maintained by the maintainers that are currently there. And I think that's actually a very sort of important point, because you could merge anything into MoveIt. I mean, we just saw from the example apps and the which is fine. I mean, they're sort of separate, but we also saw the extrinsic calibration wizard, for instance. And if from a maintainer's perspective, if that gets merged, it essentially means that either there needs to be a maintainer who has sort of the ins and outs of all of that, or the other maintainers somehow need to become aware of how this works and then start maintaining it. So even from that perspective, I would say, sort of don't put everything into MoveIt, but that's more a logistical point. I would say, obviously for users, it's nice that they can just go and have a one-stop shop, but it comes at a price, and I think we should be careful to not diversify too much, because it's just very difficult to maintain these kind of things. I've seen it myself in Ros Industrial, actually. It's very nice to put everything on the Ros Industrial organization, but people also expect you to maintain it. And we have two organizations on the MoveIt side. There's a few repositories, but if you put everything in that one repository, it's part of MoveIt, so people expect you to maintain this, and I'm not sure whether that's feasible.
I think there's some room for expansion, though, so I'll push back a little bit. I agree that maybe perception is kind of pushing things too far, but so right now in MoveIt, there's sort of a strict separation between path planning and control. And I think that could be, there's probably more room for integration there. There's more things that can be done in synthesizing controllers along with plans that are now sort of done in a completely coupled way, or decoupled way. Imagine that you're sending a surface, you definitely want to reason about the controls along with reasoning about plans, and at the same time going to a higher level of abstraction, the task planning that Robert is going to talk about, that's sort of another sort of higher up over longer time horizons, reasoning over discrete actions that, well, now we're getting into AI territory, doing task planning, but it still seems like it's incredibly useful to be able to reason about the feasibility of actions, which requires you to do path planning before even coming up with a task plan. So it's kind of, well, can't completely decouple it. There's some things that are just, things are going to break if you do it in a completely hierarchical way, and people are wondering why it cannot be done when in their mind it seems clear that it should be possible. And it's like, well, that's just because we've drawn the boundaries between layers of abstraction in such a way that it cannot be done. And that's sort of always a compromise you have to draw, right? So yeah.
I also interested in the connection between planning and control, and especially if you look at industrial robot, there is very interesting features like you can change the speed of the robot from 0 to 1, and that is not, ideal myself, because we always send the robot about, okay, let's go from here to there by 3 seconds or 4 seconds, but there, how can I say, unit is 1 to 0. So 1 is the maximum speed, and 0.1 is very slow. So when we think about such, but that is very useful, because if you look at the IROS next weeks, you look at a lot of videos, but all the video there is some times 4 or times 10 videos. So it's very slow. And always people ask us, why it's so slow? Because robot hardware has the ability to make more speed. But researchers always be, how can I say, conservative to, we always fear about breaking robot, and we always put, okay, 10 seconds or 5 seconds, 2 seconds. So if you can change like that, it's very useful. And if we want to implement that feature to the MoveIt or any systems, we have to think about some coordinate between controller and the planner or some interface layer. And I think for me it's very interesting, and of course, it's dangerous to make MoveIt bigger and bigger and bigger, but these two parts not be easily dividable. It have to have some very close connection between them.
Yeah, and on that thread with regards to the scope of MoveIt, you know, I think there is definitely arguments for and against expanding MoveIt, but if you had to pick out and I'm opening this question to all of you guys, but the most important feature that you would add, or if not a new feature, biggest improvement on an existing feature, what would it be?
Well, just to answer the previous one there.
Sure,
since
go
I
ahead.
got down here. I do agree that like integrating more towards the controls end makes a lot of sense, particularly for that whole dynamic planning and whatnot aspect. I think at all of those levels, though, like good either whether they're ROS APIs or they're plugin APIs, having those APIs defined, even if you don't even have much of an implementation available in MoveIt proper, right, for things like perception and whatnot, so that you have an API of how you get that data in. Is super useful because perception is an area that's still evolving so rapidly that even if we went and merged something into MoveIt today, it's probably out of date in the next 3 weeks. And then, you know, you can't keep updating it all the time, but allowing, you know, external repositories as much as Dave loves his one repository for all of MoveIt, like they're having those plugin style APIs so that things can exist outside of it. And in the navigation stack, right, we have, I think we only ship like 2 planners in the whole thing, right? And there's like 5 or 10 more that are independently developed and maintained outside of that. And when your use case calls for something different, you can go find that from a third party at that point. As far as things to add, I'm really big in mobile manipulation, and it's one of the areas I think we don't support very well as a use case within MoveIt, which it seems like it should be something that would be straightforward. If you have a holonomic base, you kind of can get it to work as long as you keep the region small and whatnot, or your octomap kind of blows up. But there are some various bugs around that and whatnot, and certainly it doesn't support diff drive robots, which is, I think, the majority of robots out there in the world today. So yeah, mobile manipulation I would think would be sort of my top wish list item.
Oh, me too. So I need a mobile manipulation support for that because, of course, we use a mobile manipulation robot. And also, for me or other people, I think the MoveIt is kind of the gateway to the ROS or robot. So, I mean, when you have a robot, and if you are a beginner and you listen that, okay, ROS is very good for the robot. So what people should have to do in the first? So maybe it's very hard for people to ask to, you know, bring up the Emacs and write the programs. But if you have a MoveIt interface and that can, you know, control the robot, that will be good. So this is why people love MoveIt, because if you launch the MoveIt, then you can somehow control the robot, make some movement, some motions. But it's only, at this moment, it only works for the manipulation robot. And if you have a mobile robot, you can't use a MoveIt for the gateway to the ROS-based robot. So I think that, you know, support for the mobile robot and also support for the mobile manipulation robot can keep the MoveIt as a, you know, gateway to the ROS-based robot, and that is very good, I can say, feature of the MoveIt. So I think that.
So there's 2 things that I would like to see in MoveIt. One is that actually something that we're actively working on. I know that Dave feels very strongly about this too. This is based on his thesis work on experience-based planning. Basically, we don't solve every problem as if it's an entirely new problem that we've never seen before, because most of the time in any motion planning problem will look similar to something that has been solved in the past. If you can capture some of that prior experience and exploit that, that seems incredibly useful. Intuitively, it makes a lot of sense. There's a working prototype, but we need to sort of basically harden it and make it useful for, you know, general purpose robots. So that's one thing. The other thing is sort of related to the mobile manipulation, is where for robots that have multiple move groups, where we can automatically figure out which move groups are necessary to use to achieve a certain action. Like maybe I need to drive a little bit and move my arm, maybe I need to do both at the same time. We don't know a priori what is necessary, and having the user choose, okay, I need to drive this much and then switch to arm planning. It seems not ideal. It would be nice if the robot could figure out on its own which move groups to use when, but that's, you know, a hard problem. So I don't think there's a a timeline for getting that into MoveIt.
That's a really nice feature. Yeah, that would be great. Yeah. I'm lazy. I'm a software engineer, so this does my work. I have a very sort of specific feature actually that I personally need. So if we're doing wish listing, then use it. I would like to see more time parameterization work, especially more sort of the industry standard. Again, builds plugin, does trapezoidal stuff, great. But I have a bunch of robots that require jerk limited trajectories, and trapezoidal is not jerk limited. It basically has infinite jerk at the start, at least the typical implementations. So I would like to see more work on timer parameterization plugins, specifically for sort of using the standard industrial approaches that do actually exist. It's just very hard to implement them right now because you need to find people with the right background, and it's just nasty work that we typically don't want to do. But I think that would actually help getting it into more industrial use cases as well.
Right, so, okay, everyone heard the wish list, now get to it. No, I'd like to...
I have one of these shirts, right, so it's very sort of dangerous for me to...
Yeah.
I'm partially responsible.
Yeah. So I'd like to leave some time for questions. Any questions from the audience here with regards to the ideal MoveIt user or any of the comments made by our panel today?
Seems like we answered everything.
Yeah, we got one back in the back. 1 second.
So this is coming from more of a novice of MoveIt. How do you see the collection of like motion-based planning across robotics? Do you see MoveIt just for manipulators, for arms, but do you see also like more general for navigation? I feel like there could be more collaboration between the navigation and MoveIt in terms of having a robotics planning library.
Is there anyone in particular that you're asking this of?
No. I remember when I first saw MoveIt, it had like an infographic of an autonomous car with like the Ackman steering model, and I haven't even seen MoveIt being used for Ackman steering again. It's like, what's up with that?
So I'll just give a very brief comment. I mean, from the planning perspective, there's obviously no difference. And I think even, OMPL itself, for instance, doesn't have any kinematic model internally. So it just depends on how MoveIt would pass down this information, and we just happen to typically use it with arms, which happen to be serial manipulators. Anything else should be possible, it's just that right now it's not in there. I can definitely see that being added, yeah, sure, why not?
Yeah, it's one of those examples where, for very specific instances that are very common in lead navigation, there are very specific planners that work really well for that domain. And yes, you can use a generic planner in OMPL, but it's probably not going to do any better than a specific navigation planner. So it can be done, it's just in practice, it's going to not result in any significant improvements, I would say.
What about for like that piano moving problem? Like that's not a common thing we see in the navigation stuff.
Yeah. Yeah, so as soon as you're doing navigation with in more complex environments that require you to sort of wriggle through narrow spaces, then yeah, there's probably room for MoveIt to do something better, but that's, I guess, not the typical use case.
So maybe, I think if you have a good mobile manipulator, then that problem comes very, that request comes to the developers, because if you have a mobile manipulator, people start from the arm navigations, but soon they want to have a whole body manipulation, what we call that, connecting the arm motions and base motions. Then I think the MoveIt will support that, features, support for the navigations. So I think to support the navigations, I think the good way is first we focus on the mobile manipulation robot, and then we can have the navigation features in the MoveIt.
Yeah, I think it's definitely something that's possible, but I think there are also the two different systems, navigation and MoveIt, right, are optimized for different use cases, right? And neither one of them is particularly, well, obviously navigation can't do any of the use cases that MoveIt's doing. MoveIt probably could do a number of those, but particularly in like large environments, you would have to do some fairly large overhauls of like the world model and whatnot and move it in order to actually make it really tractable and feasible. So yeah, I think that you lose some of that aspect of optimization when you try to make something that, you know, more generic, right? And so you sort of end up with that specialization keeps the two things kind of coexisting. I don't necessarily, I think as we get more controls aspects, you know, as we get closer to the controls aspect and we sort of split into this aspect that we have like global and local planners within MoveIt, like we're a step closer, but then there's also still that world model aspect to deal with.
I think we had a question in front.
Thank you. I've got one comment and one common question. The first one is about Python. I didn't mention this in my talk, but I can't stress how much Python made my life easier when I worked with the students. It seems like a thing of nothing if you're deep in computer science, but it's not. It's a huge deal. It makes it so much different for them. I actually had that wrapper for our functions written in C++, and I couldn't give it to the students because they didn't get it, and it also took me 3 times as long to write. So it was kind of a waste in the end. That was my comment, and the common question is, I found it really interesting that Okada sensei said to him, ROS or MoveIt is sort of the gateway to ROS. And I think that reflects a lot of the user's experiences in real life. It's the first thing you really see moving a lot of the times. And I wondered if that's not because maybe as a professor, and me as a sort of newcomer, we're more acutely aware of the pain and the costs of starting up in ROS. And what I wondered is, what is MoveIt to you on the panel at the moment? Is it the gateway to ROS? Is it a tool for research or for implementation or something else entirely?
Yeah, that's an interesting one. I guess part of that is also that MoveIt has got really good advertising going on for it, right? You know, I would guess that navigation is also somewhat of a gateway, depending on the type of robot that you're on, but it has nobody advertising it. So it's just kind of, you have to find it, which is obviously hard in a lot of ROS. I think that's a pretty high starting point for ROS also, though, like to say that MoveIt is the entry point. So I find that very interesting because that really is like probably the most complex thing in ROS to jump right into. Seems like maybe not the best way to jump into ROS, and perhaps if it really is the entry point, that's part of why people complain about ROS being so hard to learn, is that they're actually convoluting a whole bunch of different things together. So yeah, that's interesting. Python interface, and I actually had thought of something after we were talking about that, just to go back to that for a second, was yeah, I definitely agree that, you know, Python for getting people into things makes a lot of sense. The MoveIt commander itself, I don't know that that's necessarily the piece of code to use, because I know that has all sorts of weird things going on with like C++ wrappers in Python, and it ends up as like 2 nodes in the system at a time, half in Python, half in C++. And so if you pick the right API level, you know, I actually have a package called MoveIt Python that it doesn't do most things in MoveIt. Like, it does just the key things of like, hey, you can get pick, you can get place, you can, you know, move your arm and whatnot, but it's pure Python and it's at the ROS API level. So again, I think it's one of those, if you pick the right API level, you know, that ends up being pure Python, just, you know, using the ROS interfaces. And obviously it's not super high performance the way that you might get if you have like some C++ node, but it's a great starting point at that point.
Real quick, if we can just, one more comment or reply?
I'm very pragmatic, so I see MoveIt as a tool, really. It serves a purpose, it has a number of use cases it covers, and if I have one of those, you know, use cases, I want them covered, I use MoveIt. So, but, you know, I'm just happy that it exists, because otherwise I probably would not be able to do what I do now.
Great.
Not as inspired, perhaps, as you were looking for, but, you know.
Same for me, yeah.
Great. All right, can we give you a round of applause to the panel? Thank you.